Hey kiddos, today we're going to start on Unit 7, which is really kind of a mini lesson or mini unit. We're just going to have two lessons to kind of wrap up stuff about quadratics, okay? So what we're going to start with today is kind of a review for Math 1. How do you look at a table or a graph or an equation and determine if it is either a linear model or a quadratic model? Okay, so let me just zoom in so that you can see our review. So for a linear function, we have our y equals mx plus b, our slope-intercept form. How do we graph? Well, we're going to plot the y-intercept and then use the slope to plot more points. And if you want to determine just by looking at the table if it's linear without graphing it, you could take all the differences of the y values. If the first differences are equal, then it will be a linear function. Okay, let's take a look at quadratics. This is our standard form, y equals ax squared plus bx plus c. Remember, to graph this, we need to identify the vertex, the y-intercept, any zeros that we can find, plot all those points, and connect them with a nice curve. Again, if we just want to look at the table to determine what type of function that we have, you can look for either repeating y values, or if you don't see any repeating y values, you can take the second differences. If the second differences of the y values are equal, then you know that you have a quadratic function. So let's go ahead and take a look at number 1, example 1. Okay, so we're going to determine what type of model this is. So let's just go ahead and plot the points. I'm trying to find a pen. I guess that one will work. Okay, so let's go ahead and plot all these points. -2, -7, 0, -3, 1, -1, 3, +3, and then 5, 7. Okay, and so this looks like it's a pretty good linear model for me. Let me use just a straight edge real quick here and connect all these points. Okay, so this is a linear model. All right, so how do we determine if this was a linear model by just looking at the table? Let's take our differences. -7 minus -3 is going to give me -7 plus 3 is going to give me a -4. Okay. -3 minus -1 is also going to give me good gracious. Let me do it this way. 7 minus 3 is 4. 3 minus -1 is 4. -1 minus -3. Oh, I see what's happening. These are not, if you look at my x values, they're not going in numerical order. -2, 0, 1, 3, and 5. So that's causing it to kind of not work out right for me. So that can be a little tricky when your x values are not going in numerical order. All right, but if they are, these first differences should work out well for you. In this case, most of them are working out, but not all of them. Okay. So now how do I determine the equation of this line? Well, my y-intercept is right here at -3. And then my slope is rise 2, run 1. So my equation is y equals 2x minus 3. Okay, let's look at our quadratic example. Now, there are two different ways of looking at this immediately. Well, one is by graphing. We'll do that in a second. The other is by looking at the table, and I see this positive 2 and this positive 2 repeat, the negative 1 and the negative 1 repeat. So I can tell you already that this is quadratic. Okay, let's find our differences. Now, these are in order, so this should work for me. So what is 2 minus negative 1 is 3. Negative 1 minus negative 2 is some scratch work. Negative 1 minus negative 2, so I got to add, and I get 1. Okay. Negative 2 minus negative 1 is going to give me a negative 1. And then negative 1 minus 2 is negative 3. So that's the first difference. Let's now find the second difference. Okay, so 3 minus 1 is 2. 1 minus negative 1 is 2. Negative 1 minus negative 3 is also 2. So you can see that the second differences all give you the same value. So this is definitely quadratic. Let's go ahead and plot our points. Negative 1, negative 2, negative 2, negative 1. I plotted that wrong. That should be down one more. And then these should be up here. And then positive 1 up 2. And up 2. So this, ignoring that one point that I made a mistake with, this is what my equation should be. Now, the easiest way to write this equation is going to be in vertex form because I know my vertex. Okay, so I'm going to get y equals x plus 1 squared minus 2. So actually up here at the top of my notes, let me add vertex form. Okay, so you could also have y equals x minus h squared plus k. So we do know two different ways of writing a quadratic. Okay. Okay. Now that we've talked about linear models versus quadratic models, let's take a look at systems of linear and quadratic models together. So remember, a system is just where two functions share the same graph and the points where they intersect are the solutions. Okay, so let's go ahead and do our graphing example. I'm going to use this teal color for my linear functions today. So my b is negative 3, 1, 2, 3, and my slope is 1 over 1. So here is my linear function. All right, and I'm just going to connect these. Next, I have my quadratic function. So I know that the y-intercept is at negative 6. So here's the y-intercept. Now what I just need to do is factor this to find the zeros. Okay, so negative 6 and negative 1 in the bottom, so negative 3 and positive 2. So my factors are x minus 3, x plus 2, which means that my two zeros are located at positive 3 and negative 2. So negative 2 and positive 3. And then what we can do is we can Try to connect these with a nice curve, okay? And I'm pretty awful at it. Okay, and so we do have two solutions here. Our two solutions are located at -1, -4, and +3, 0. Okay, so this is -1, -4, and this is +3, 0. And those are my two solutions. Okay, and that's all there is to it. Okay, graphing using all the different methods that we've already learned for quadratics. Okay, let's take a look at example 4. We're going to use this or solve this using the substitution method, okay, which we did back with systems of linear equations. But now let's go ahead and do it when we have a linear and a quadratic, and it works the same way. So the first thing I need to do is put both of my equations in y equals form. So let's go ahead and solve this for y equals. So subtract your two x's. Okay. And now I'm going to substitute the linear equation into the quadratic. So this equals y and this equals y. So instead of y, I'm going to replace it with my linear function. -2x plus 2 is going to equal this here. All right. And so now what I need to do is solve this by multiplying out this squared binomial and then moving everything to one side and factoring it. Okay. So x squared minus 2x plus 1 equals this here. Let's go ahead and move everything to one side. So I'm going to add 2x and add 2x. And then I'm also going to subtract this 2. Subtract this 2. So now what I have is 0 equals x squared. 2x minus 2x cancels. 1 plus 1 is 2 minus 2 cancels. It doesn't always work out that way. And so now I'm ready to finish solving this. Well, I have an x squared, so let's go ahead and take my square root of both sides. So I get plus or minus 0 is what my x value is. So in the case of a 0, we don't actually need to worry about the plus or minus. We're only going to end up with one solution for this. Okay. So now I know that the x value is 0. Here's what I'm going to do. I'm going to just plug this in right here. So now I have, and I need to solve for the y. What is the y value going to be? -2 times 0 plus 2. And so -2 times 0 is just 0. So y equals 2. And so here's my solution. I take the x value and the y value, I put them together, and that is my solution. Okay? All right, kiddos, we just have 2 more examples to do. And these are going to be applications. We're going to do one of these applications by hand and the other one using the Desmos calculator. All right, so let me zoom out so that we can see all of it. So the revenue for a production by a theater group is equal to this equation, where T is the ticket price in dollars. The cost for the production is this equation. So this is revenue and this is cost, okay? Revenue is what you bring in, cost is what you have to put out. Determine the ticket price that will allow the production to break even. And then there's a note here. A company breaks even when the revenue equals the cost. The amount they earned equals exactly what they spent. So let's go ahead then and set these two equations equal to each other. They both are already set equal to y. So here's what we're going to do. 600 minus 50t equals, and then I have negative 50t squared plus 300t. Okay, so what I want to do right now is I want to move everything all to one side of the equal sign. So let's, to both sides, I'm going to add 50t squared and subtract 300t. And now that side equals 0. And let's write our new function. So 50t squared, negative 300 and negative 50 is negative 350t plus 600. Okay, so I'm ready to factor this. The first thing that I notice is that I have three numbers that are all divisible by 50. So I have 50 times 1, 50 times 7, and 50 times 12. Okay, so I'm going to factor out the greatest common factor, which is 50, and then I'm going to write my leftovers. 1t squared minus 7t, and then plus 12. Okay, so I took out that GCF. All right, now I'm going to go ahead and do the X puzzle here. What two numbers can multiply together to give me a positive 12, but combine to give me a negative 7? So it looks like negative 3 times negative 4. Okay, so t minus 3, t minus 4, and bring down my 50. And now I'm going to use my zero product property. So here I have 50 equals 0, which is not true. So I throw that answer out. T equals 3, t equals 4. So here's the answer. Determine the ticket price that will allow the company to break even. Well, it can break even at both or either, let's see, T is the ticket price in dollars, so at either $3 or $4 per ticket. And that might not seem like it makes sense, but if your ticket price is cheaper, more people are going to probably go and want to watch. If it's a little more expensive, you're going to earn more money for each ticket, but maybe less people are willing to go. Okay, so at either $3 or $4 per ticket is my answer. Awesome. Okay, last question for today. A daredevil jumps off of a tower and falls freely for several seconds before releasing his parachute. So his height in meters after jumping can be modeled by this, but before he releases his parachute can be modeled by this. So here's what we're going to do. We are going to treat this kind of like a system of equations, and we're going to go graph them both on the Desmos calculator and see where they intersect. So we're solving a system of quadratic and linear equations, one by hand and one by graphing on the Desmos calculator. Okay, so let's go take a look and see what we get. Okay, and let me open Desmos. And then I'm just going to type in the exact equations the way that they gave them to me. Just remember to change h and t to y and x. So y equals negative 4x plus 142 is the linear equation. The quadratic equation is y equals negative 4.9 x squared plus x plus 360. Okay, so I'm going to have to zoom out. Okay, here we go. I'm going to adjust my graph so I can see where these two cross. And so at negative 6 seconds is one answer, and the other answer is at positive 7.2 seconds. So negative 6 seconds or positive 7 seconds. Okay, so we've graphed this and we found the 2 points of intersection. Now, because this is an application problem, let's go back and talk about which one that we throw away. And it's going to have to be the negative, okay? Time cannot be negative. And so at 7 seconds is when he opened his parachute. All right, kiddos, that is our lesson for today. There is a practice for you on Canvas. Alrighty, until next time.